Hi everyone. What is the recurrence equation or recurrence relation? How can we use recurrence relation for calculating the time complexity of written algorithm? The recurrence is an equation or inequality equation that is describing the function, that is the number of steps with respect to its value over the smaller values. That means we will segregate the biggest problem into smaller problems. So the for the smaller problems we will find out the values. First, derive a recurrence equation of a written algorithm, that is finds the subsequent term which is depending on the preceding term. That means the next term is depending on the previous term of the equation. Here, when we can use the recurrence relation, so whenever we are applying the divide and conquer method by partitioning the bigger problem into smaller problems, here n is divided into half of the problem. One half is n by 2, another half is another n by 2. Then again we can divide this into n by 4 and n by 4, and again all the n by 4 can be divided into n by 8, n by 8. Again n by 8 can be done for n by 16, n by 16. It will keep on go until n by n, that is 1. Okay, so it will keep on do for all the sub problems uh, like this. So then you will find the solution for each and every sub problem. So for this on we will get the one solution. For this we will get the solution, then we will return back to combining all the solutions to obtain the original solution for the bigger problem n. So first we are dividing into smaller problems, then we are solving that smaller problems, combining that smaller problems into get the original solution for the problem size n. So that's what given here. If the problem is smaller, then we can find the solution without dividing. Otherwise we will divide that bigger problem into smaller problems, that is k number of problems. Then we will apply the divide and conquer method to each of the sub problems. So we will get k number of solutions. Then we will combine all the solution together to find out the original solution. So here we will calculate the number of steps for the given algorithm. For example, t of n. So earlier we have used the f of n, but in recurrence relation we will use the t of n, time complexity, that is runtime, number of steps for the given function with respect to input size n, that is represented as t of n. So here we will solve that recurrence equation or recurrence relation by computing the order of growth function of written algorithm. The order of growth is the function t of n here. Three methods can be used to solve the recurrence equation to analyze the written algorithm. Here iteration method also can be used. In this, first we will iterate the recurrences one by one until n number of times. Then we will express it as a summation of the terms which is depending only on the problem size n and the initial condition. And second method is substitution method. Third one is master theorem. Here for the recurrence equation we have taken the problem factorial of n, so that is n factorial. So here the recurrence equation is given, that is the function by calling itself again and again. In previous method, by using the operations count, what we have done, we will pass the value. Suppose if you are passing the n equal to 2, here the if n equal to 0, which is returning this one, but now n equal to 2, now which is calling the function this one, n 2 into factorial of here 2 minus 1, that is 1. So one time it is executed, then again it is going back. Now the value is 1. So 1 here we are checking, already it is one time checked, so this is second time. It is false again, then which is coming back to the factorial this one. So now n value is 1 and factorial here 1 minus 1 equal to 0. So now again calling here factorial of 0. So now it is true. So it is true, that is now third time it is calling, then return 1. So this is one time. So this is three times executed. All right. The function which is called two times. So we can say this one, as in the previous term, previously we have used function of n. Okay, function of n equal to, so this is two times, 2 is the n here. So 2 n, right, that is sorry, n, okay, plus this constant amount of time 3 plus 1. So here we can say n plus 4 equal to order of n plus 4. Then we will ignore the lower order term, we will get order of n. So this is what we have calculated by using the number of step, by using the count variable, by using the number of steps. Okay, but in recurrence relation we will use the t of n by calculating the how many times this factorial of n minus 1 is repeatedly calling, recursively calling. So this is calling for n minus 1 times. Okay, so we will take t of n minus 1, then plus here we are getting this one is some n times, that is the number of times, constant amount of time. So this is also constant amount of time. So here we will get, suppose for example if you are getting the 4, then we can bring this into uh, single I mean small constant value 1. So whatever value you are getting, even 100, that can be bring into 1, or you can use the variable some c constant. So here we are making that into the 1. So here now we will use the time complexity here, t of n equal to t of n minus 1 plus 1. So next, yeah, when you are substituting the previous term, so t of n minus 1, when you are substituting this here, the we will substitute in the place of n minus 1. So when you are substituting the t of n minus 1 minus 1, then this is the t of n, okay, plus 1, the entire term we are substituting plus this existing 1. So this term is for t of n minus 1. Okay, t of n minus 1. So now when you are getting substituting this one, you will get t of n minus 2 plus 2. Then when you are substituting the next term t of n minus 3, then in the place of n you have to substitute the n minus 2, n minus 3, like that. Keep on, you have to do it k number of times or I number of times. So when you are substituting the I number of times, you will get this format n minus I plus I. So when n equal to I, then you will get t of I minus I plus here you will get n. Okay, because I equal to n. So we have got n here, we got the t of 0. So we have got the t of 0. So t of 0 equal to 1. So whenever the t of 0, that is t of 0 means 0 factorial. So when you are passing the 0, it will check the condition, yes it is true, so it will execute only one return statement. So you will get the value 1. So this is one time, this is one time. So 1 plus 1 2 times, the 2 is considered as a 1 as per this constant, small constant. Okay, so now we are substituting the 1, or you can use the c also. Then here we have the n. So finally we got n. So this is the order of n. So time complexity for the factorial number by using the recurrence equation. Thanks for watching.